In this video, we're going to look at network covalent atomic solids. So what is a network covalent atomic solid? Well, they're solids where your atoms are held together by covalent bonds. Covalent bonds are very strong, and so for a solid to melt, you have to break these bonds, which means these compounds have extremely high melting points. One common example is carbon. And carbon will form a crystal in two different forms, graphite and diamond. Graphite, you have your carbon arranged in flat sheets, and they're arranged in these hexagonal rings. Now, between the rings, there's actually no bonding whatsoever. So these sheets just slide past each other very easily. That's why graphite is usually good for writing, and it's also used for lubricant because it's very slippery. Diamond, on the other hand, forms when you have graphite and it is exposed to extremely high pressure and temperatures. Pressures of 50,000 atmospheres and temperatures of 1600 C was necessary in the lab to make your first synthetic diamond. Here, our diamond is in a face-centered cubic structure where you have additional carbon atoms in half of the 8 tetrahedral folds below each corner of the atom. Here. It's very similar to that zinc blend we saw in the previous videos. Now, unlike graphite, diamond does have covalent bonds between each sheet, so you can think of diamond as one giant molecule. And since you have extra covalent bonds, it's even harder to break or melt diamond than it is graphite. In fact, diamond has an extremely high melting point of 3800 C to turn solid diamond into liquid diamond. Now, other forms of carbon that exist in the world, here I'm showing you a buckyball or a fullerene. This is 36 to 100 carbon atoms arranged in a sphere or a soccer ball because you have these 6-membered rings and these 5-member rings, which looks a lot like the pattern of a soccer ball. Now, this was first discovered by taking a carbon compound and shooting it with powerful laser, shooting graphite rather. And through these experiments, we also created long nanotubes. A nanotube is 6 carbon hexagonal rings that forms a tube with closed ends. And you can open these ends with heat. You have single wall variant or multi-walled variants as shown here. Now, these nanotubes are extremely strong, roughly 100 times stronger than steel, with only 1/16 the density. This is why you'll see these carbon nanotubes or nanofibers in golf clubs or bicycle frames. You get a lot of strength for a little weight. And the last compound we're going to look in this video are our silicates. Silicates are silicon and oxygen compounds. These are your most common network of covalent atomic solids. It's estimated 90% of the Earth's crust is made out of these silicate compounds. And the silicate is simply silicon bound to 4 different oxygens. And each oxygen, as you can see here, we only have 7 electrons. So each oxygen is actually bound to 2 silicons. So you'd have a silicon here, 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 and here. This compound, once you have the network, is called silica. And the 3-dimensional structure these form, we call it quartz. So if you've ever seen a quartz diamond or a quartz ring, that's just silica, this compound. And that's it for this video. I will see you in the next video.